Trig identities. So when we're given a trigonometric equation or an expression, sometimes we can simplify it by using what we know about trig identities. For example, on number 1, we have cosine of alpha times cosecant of alpha. Cosecant we can just rewrite as 1 over the sine of alpha. So now we have cosine of alpha times 1 over the sine of alpha, multiply straight across, and I have cosine of alpha over sine of alpha, and that's one of our identities. That's equal to tangent of alpha. This one, we have 1 minus sine squared of alpha over sine squared of alpha. Well, 1 minus sine squared of alpha reminds me of my trigonometric Pythagorean identity, where I have sine squared alpha plus cosine squared alpha is equal to 1. Similar, but I can solve for my cosine of alpha. If I solve for my cosine of alpha, I have cosine of alpha is equal to 1 minus sine squared of alpha, and I have 1 minus sine squared of alpha right here. So instead of 1 minus sine squared of alpha, I can substitute in this cosine squared of alpha. So cosine squared of alpha over sine squared of alpha. Cosine over sine is tangent, and is cotangent, and so cosine squared of alpha over sine squared of alpha is cotangent squared of alpha. Now here's a good time to talk about some conventions that we have with our trigonometric functions. So when we have sine squared of alpha, that's really just sine of alpha squared. We're not squaring the alpha, we're squaring it after you've taken the sine of something. So it's just written like this. If you like to, you can put parentheses and write a squared over the whole function. But that's what you're doing, is you're taking the sine of that angle and you're squaring it. So cotangent squared of alpha. So if we have something that looks like this, looks a little more complicated, we have 2 times cosecant squared of theta minus cotangent squared of theta. And when we have these cosecants and cotangents, we want to look at the cosecant-cotangent identity. So cotangent squared of theta plus 1 is equal to cosecant squared of theta. And so I can take this and I can solve for 1 here. And when I do that, I have 1 equals cosecant squared of theta minus a cotangent squared from both sides. And I have 1 equals cosecant squared of theta minus cotangent squared. So this is the same thing as 1. So instead of this value, I can substitute in the 1. So 2 times 1 is just 2. And the way I would write that is 2 times the quantity of cosecant squared theta minus cotangent squared of theta is equal to 2. So that's a much simpler expression than my original one, just using my identities.